Mary, can I slide this right here? Does that bother you at all? I want to get as close as I can so the picture quality is at least somewhat decent. Okay. All right. Our focus today is on graphing complex numbers and taking their absolute value. You've graphed before on an XY axis that looks just like this. You've graphed ordered pairs. The x-axis is the horizontal axis running left and right. So doesn't the x value in an ordered pair tell you how much to move either left or right to find that point? Yes. Now the y-axis is the vertical axis. So the y value in an ordered pair tells you how much to move up or down. We're the y-axis when we graph complex numbers with the real axis instead of the x-axis. The real axis runs left and right. The imaginary axis replaces the y-axis. This is the vertical axis. It goes up and down. To graph a complex number, I break up the real part. That tells you how much to move left or right. With the imaginary part, that tells you how much to move either up or down. This is pretty easy. You can graph ordered pairs. You can graph complex numbers. Let's graph 3 minus 4. What's the real part? How much is the real part worth? 3. So go right 3. On the real axis, the real part is worth positive 3. So I go from the origin, right 3, like I'm plotting a point. How about negative 4i? What's the imaginary part worth? So from here, now I go down 4. No, it's like plotting the coordinate 3 comma negative 4. I'll even label it as 3 minus 4i. Instead of x and y axis, now it's just the real axis and imaginary axis. The real axis, this number tells you how much to move left and right. This number tells you how much to go up or down. You can, but I probably won't give them to you like that. Well, negative 4 plus 4i. Where would that be at? Negative 4 plus 4i. What's the real part worth? So go from the origin, instead of right 4, now I go left 4. The imaginary part is worth 4. So from this point, after you go left 4, now I go which direction? 1, 2, 3, 4. Boom, there you go. Left 4, up 4. Here's the coordinate, negative 4 plus 4. About negative 2i. What's the real part worth? I don't see a real part, so the real part is worth 0. I don't go left or right at all. From the origin, I move left or right, nothing. But I do need to go somewhere. Down 2. Simple, right? Easy. Graphing complex numbers. Any major concerns there? No. It's like graphing points. But instead of x and y, now it's real and imaginary. Okay, now let's do absolute value. You can graph the imaginary number. We can also find its absolute value. Remember back to algebra 1. Absolute value tells you what about a number?
It's absolute value.
Sure. What does absolute value mean? For example, what's the absolute value of 2?
2.
Y r is away from 0. Absolute value is the distance from 0. What's the absolute value of negative 3? Because isn't negative 3 just 3 from 0? It's just 3 less than 0. Okay? We can do absolute value. But we can do it by thinking about how far it is from the origin. For example, let's take the absolute value of 3 minus 4i. Absolute value is these two vertical bars. Absolute value is how far this point is from 3 minus 4i back to the origin. What's that distance that I've got for my dotted line in red? That's the absolute value of the number 3 minus 4i. How far is it back to the origin from where I graphed it? How can I get that figured out? How can I figure out how far it is from here to here? From 0 or the origin to the value 3 minus 4i.
You can count the.
Well, it's kind of hard to count diagonally.
No, I know the lines, the down and no.
You're saying down?
No, not
Like how far it is from here
Yeah.
to here?
Yeah.
What's that distance?
4.
If I count up and down 4, how about I count how much left and right? What's this distance? What did I just draw? A right angle, sure, but more specifically, isn't that just a right triangle? So how can I figure out that missing side length in the right triangle if I know 2 of the sides are 3 and 4? I know 2 sides in a right triangle. How can I find the missing side length? How can I find this absolute value length?
A squared plus b squared equals c squared.
Sounds right to me. What's that called? Pythagorean's theorem. Can't we just do Pythagoreans?
Yeah.
A squared plus b squared equals c squared. C represents the hypotenuse, the longest side, opposite the right angle. So, all right, 3 squared plus 4 squared equals c squared. C is that distance we've got for our dotted line, the distance from the origin or 0 out to the point 3 minus 4i for our value. 3 squared plus 4 squared. 9 plus 16 equals 25. C squared. 9 and 16 make 25. How do you get rid of a square? What's the absolute value? The absolute value of 3 minus 4i is 5, because that's how far it is back to the origin. We proved that using Pythagoreans.
Couldn't you just count?
But I have to count this way.
Yeah.
I can count left and right. I can count up and down. It's much harder to count diagonally.
But you just counted the origin. So 1, 2, 3, 4, 5 to the bottom. That's fine.
But it's 1, 2, 3, 4, 5 to the bottom. I've gone too far.
But what if you just counted the origin? That's 1, not 4.
But that's 0. You can't call this 1 because you haven't moved anywhere yet. I haven't moved the length of 1. This is 1, then 2, then 3, then 4. Instead of counting diagonally, count how much left and right, count how much up and down, and then just use Pythagoreans. Let's do one more. Let's do negative 4 plus 4i. What is the absolute value? Negative 4 plus 4i. Well, let's just draw a right triangle. How far is it to the left? From the origin to the left, how far did I draw it to the left?
4.
We'll just call it 4, though. We're going to move left 4. Distance is always positive. I see what you're saying. How about to the top?
You got 4 again.
4 again. So I need to figure out what that distance there is in blue for the distance back to 0 for our absolute value. A squared plus b squared. Negative 4 squared plus positive 4 squared equals c squared. 4 squared is 16, so I have 16 plus 16 again. 16 and 16 make 32. Now to solve for c, to find the absolute value, I take the square roots. How is the square root of 32 different than the square root of 25 then? Sure, so I can't just simplify it and call it an even 5, right? I need to simplify the square root of 32. What perfect square divides into 32?
8, no.
8 does. How many times?
Oh, those are really 4.
There's
Yeah,
also
that's-
16.
You could also do 16.
Whoa, chill.
What's the square root of 4, Landon?
2.
Now keep doing 8.
4 and 2.
4 and 2 again.
Whoa.
Square root of 4 is still 2.
2,
Square root
2,
of 2
2.
can't be simplified. Multiply everything I got circled back together for our
8.
answer. What's 2 times 2?
4, 8.
So 4 square root of 2. Yeah, sometimes better do it for you, some doesn't. But it's important to see where that answer is coming from, right? For sure. All right. I think we'll do some practice for the rest of the hour. And maybe some focus areas in class. Let's see what we got here. Could you grab your practice for complex numbers out? The packet that looks something like this bad boy. Yes, I do.
My name is so fancy.
Yeah. Sure, grab this, please. Flip to the last page. Last page should look something kind of like this. I want you to get some practice on graphing and finding absolute values of complex numbers. Answer should be up on the television screen in red. Remember, if you have assessments that need to be redone, or any work that needs to get done on that last test, find me before Friday.
Sure? No, never mind, actually.